There you go. All right. Hello, everyone, and welcome to Networking, featuring me, your host, Kyle Coberly. By the end of this lesson, I hope that you will be able to describe the HTTP request response cycle. All right, so you've seen this diagram a couple times now. You're going to see it a lot more over the rest of your career. I want to break it down a little bit further. So you have a client and it makes an HTTP request to a server, and then the server gives an HTTP response back to the client. Ta-da! I want to talk more today about what does client mean? What does client mean? What does server mean? What is HTTP? So if we're just going off of what the words kind of sound like, client and server, give me your best guess. Anyone, shout it out. What client and server mean?
Like browser for client, and then server is computer where data is stored.
Sure. So a browser and a computer with data. Like 8 times out of 10 in this program, that's what we're talking about when we're talking about client and server. But the terms are bigger than that. Any guesses what the more abstract idea behind clients and servers is?
A server is meant to connect to many computers, but a computer is mainly, or a network of computers was originally meant to kind of all access one server, right? Or clients is meant to access one server.
Ooh.
Not that that's necessarily how it works.
Some interesting stuff. So the thing John just described was this idea that we have a server that connects to a ton of clients. That's not wrong, but it's not the only way this works. But yeah, that server being like a gateway into a network or something like that. And I really need to underscore this because I think, especially coming from a consumer, technology consumer background, it's really easy to think of these computers as different. They're not. Your API server, your laptop, your phone, from the perspective of a network, these things are identical. They don't do anything different.
So would you say the client is what makes requests and the server is what gives you responses?
100%. That is the definition of client and server. A client is somebody who's making a request. A server is somebody who's responding to a request. That is what client and server mean. So that kind of begs an interesting question. Can my server be a client?
Yes.
Sure, if it makes requests.
Yep. So when you were making your Rails, or when you have your Rails app, used REST client or something like that. All right. Well, it makes a request to that, and it gets a response. Servers talking to servers. Client and server are contextual. When your server makes the request, it's being a client. And that's why this model down here of the server that takes these requests from all these clients, that's why it's not the whole picture. because these clients in here can also request things from each other. When they're asking, they're clients. When they're delivering, they're servers. You may not have all the way realized this, but if all of you were on the same Wi-Fi network right now, you could ask for things from each other and you could deliver them back. Your computer could act as a server. And in fact, when we're all in person in the lab or something, and I'm running light server, check this shit out. I go over to something with an HTML file in it. Oh, how about my personal site? So when I light server this, all right, cool, cool, cool. But take a look at this. Localhost 3000, all right, we're familiar with that kind of stuff. You may not have like picked up on that thing right below it though. If I go to that on my phone, if I go to that on my wife's computer, if anybody on my local Wi-Fi network goes to that, like puts that in their browser, they will also see my site. So my laptop is acting like a server for some client. Hell, for that matter, you could turn your phone into a server and do the exact same thing. All a matter of context. Ask me some questions about this. It's kind of a weird idea.
Does this explain the concept of VPNs?
So yeah, VPNs are kind of like that. So if our client is my laptop and I make a request to some server that's a VPN, and then that VPN makes the request for me and then takes the response that it gets and then delivers that back to me. It is a server to me. It's a client to whatever it's making the request to. Yeah, be the exact same pattern with a VPN.
Cool.
So what is like exactly is like a server farm? Are they all requesting from each other, or are they sharing the workload, or are they just kind of operating independently?
That's a great question. So let's talk about server farms. A server farm isn't necessarily like working together on the same problem. A server farm is just a bunch of servers that are co-located together. So if I have a server farm with 8 servers on it, this one might be owned by Microsoft. This one might be owned by Google. This one is just for internal use. That's our company using these 3. And then, or 4. And then what AWS is, like basically, is AWS takes these physical computers and chops them up into virtual computers. And so each one of these is owned, licensed, leased basically by somebody who just needs a little piece of a computer. But what AWS is Amazon has these giant fucking server farms, and just like WeWork leases a building and then chops up that building into like things that it can sublet, that's what Amazon does with their server farms. They have all these servers and they chop them up into teeny little pieces and let you lease time on them. Does that answer your question, Todd?
Yeah. So that's what the cloud is.
Yep.
Okay.
It's just somebody else's computer. And 9 times out of 10, that computer is owned by Google or Amazon.
So we've kind of come full circle. Our computers are basically terminals accessing a big mainframe now, like they were originally.
Yes.
Okay.
Well, kind of. Here's the big cloud difference is so the thing that Todd's talking about is if we think about what John was talking about, where we have this central server and all these things talk to it. At an even smaller level, that's how like office computing used to work. Your office would have one computer and you would be just using a little bit of time on it through your terminal. Hey, we use terminals. That's what those terminals are like pretending to be, is exactly how you used to access them in an office. And then we got personal computers. So everybody had their own computer. So yeah, there's a similar kind of idea here, but your dumb terminal didn't actually have anything on it. You really didn't control any of that data. What's different about the cloud is that like I happen to be running this code on Amazon's server in the cloud, my code. I can also be running it on a Google server and on a Raspberry Pi in my basement and wherever else. So I still have a ton of agency with how the computing happens. The big thing that that AWS sort of led the way in is treating these computers as commodities. Because what used to happen is, and like this still happens in some people's offices, is you run your own servers. That means you make like a mail order request to CDN, to what is it? Not CDN. CDW, and you go, 3 servers, please. And then CDW mails you a bunch of computer parts, and then you have your neckbeards like assemble them and put them in a rack in the basement and hook them up to your network, and then you manage your own servers. Well, it turns out that every company was doing this, and it was a big fucking waste of time because everybody does them exactly the same. It's not knowledge work, it's commodity work. They're identical. And so Amazon realized that and made AWS. And so now, and it's like, this happened in my career when like, hey, can I have a server, please? And like, I'd have to fill out a requisition form and I'd get my server, I get the keys and the IP address for it in like 6 to 8 weeks when the IT department got around to it. Now, that's like a 20-second process on Amazon. I go, 1 regular ass web server, please. And they go, cool, that'll be 2 pennies a day. And I go, rad. And now all those people either work for AWS or are DevOps people or they're unemployed. What else? More questions about clients and servers. All right, let's talk a little bit about HTTP. So if the big picture thing is that this computer sends a message to this computer and gets a message back and then does something with it, let's talk about what's happening in these arrows. I forgot what the name I had. Well done. So we're going to call that an HTTP request. And this is an HTTP response. They always go together. HTTP is a 2-way communication protocol. If you have a request and a response is not generated, the request was a failure. Has to have both of them. I make that distinction because there's other protocols where that's not the case. But for HTTP, peas in a pod. It's got to go round trip for it to have been a successful HTTP request. So what do we do that makes HTTP requests?
Fetch calls.
Fetch calls. Fetch is our way in JavaScript of just generating HTTP requests. It's a really nice, friendly wrapper around all of that. We've actually been able to do this since about 2000, but the old way that we did it in the browser was awful. And if you don't believe me, look up XHR sometimes. XHR is still what's happening under the hood. That's why that's what in your networking tab in your dev tools, it says XHR requests. That's fetches. But fetch is new. Fetch is like 5 years old. And it's way fucking nicer than what we had before. But yeah, we use fetch to make HTTP requests. What have we done that generates HTTP responses?
Like
Routes.
Routes? Close. What part of that process in Rails?
The controller, maybe.
What in the controller?
Actions.
What in the action? What is the thing that specifically generates an HTTP?
Render.
Render. There we go. Render is how we generate an HTTP response in Rails. So for us, fetch kicks it off. Render sends the response back. Ta-da! So what is an HTTP request and response? This one, I think, new folk, it kind of like fucks them up the most. It's just characters. You can't send an object over HTTP. You can't send, it's technically not even a string. String has a length and a splice method and like lots of other things. This is just some fucking characters. And that kind of makes sense if we think about what's happening in that arrow. At some level, this is just copper wire. And the copper wire has little electric pulses on it. And we turn those pulses into ones and zeros. And then the ones and zeros get turned into like numbers. And then those numbers get matched with character codes. And then they get turned into characters. That's what's happening over the copper wire you're sending these requests over. So you can't send objects. You can't send hashes. You can't send shit. All you can send is characters. But we can do things like, I will format these characters in such a way that these computers can kind of like rehydrate objects or hashes or whatever when we get back to the other side. So let's start with requests. So there are 3 parts to an HTTP request. Does anybody happen to know what they are or have some good guesses? We've talked about them. We see them all the time. Give me any part of an HTTP request. 3 parts to it.
Is there the header, the body, and the footer?
2 of those are right. There's no footer, but there is, headers is one of them. Body is another. And then the first part of this, God, I don't even know if this has a name for it, but they all go together. It's the version, the URL, and the method. So for example, if I say HTTP 1.1 get localhost 3000 /cars, that's the first thing that we see in an HTTP request. Version, method, URL. Then we have headers. Headers are what? What are headers?
They're like the pretext, they give context to the body.
Mm-hmm.
So they typically include like the format and like the authorization if there's any authorization required.
Sure. And they're represented by keys and values. That's a big part of this. So yeah, we can say that I will accept application JSON. It's the only format that I want. I can say that the length of my request is 101 characters. I can say that you mentioned authorization. So I can send over my top secret code. Keys and values, just like a hash, just like an object in JavaScript. Keys and values. And then last part of this is a body. So I might send, well, could be something like, could just be raw characters. It could be JSON, could be also keys and values, but it's ultimately going to be just some characters. So I say user. But the part that new folks get tripped up on is that even though this looks like a hash or an object or something, it can't be. It's just some characters. That's why we need to do things like .json with responses. We're taking these characters, these JSON formatted characters, and we're turning them back into an object, not the other way around. Cool, so that's what an HTTP request looks like. And you can check these out yourself too. If you open up a browser and go over to your network tab, I just did Josh's Mod 4 Code Challenge review. Josh is like a pretty good programmer. All of these are HTTP request responses. So if I click on, let's see, if I go to this one, all right, HTTP 1.1, method was get, that's the URL. The request headers are what we sent over. If we want to look at them raw, it's just characters, keys and values. And then if we take a look at the response, well, we can see that. But really, all they sent back was these characters. Ask me more questions about HTTP requests.
So how does your computer figure out how to parse all that into JSON?
Cool. So like this one was HTML. And because in the response also has headers, it says content type, text HTML, gives me a character set also. My browser can combine those two things to give me a page that looks like this. It goes, oh, you're giving me a bunch of characters that look like this, and then you told me that you formatted them as HTML. Well, I know what to do with HTML. And so it takes all those characters and parses it and generates this like visual thing that you see. That's your browser ingesting that HTML and then rendering it. If we did that with JSON, if I narrow this down to XHR requests, so I did in version 1.1, I did a GET request to this URL. I sent over these request headers. They looked like this when I did it. And then the thing that I got back was these characters. That looks like a JavaScript object. It's not a JavaScript object. It's just characters. But it told me that they're application JSON. Neat. So in my fetch request that triggered this off, I can take these characters, do a .json on them, and it goes, oh, cool. I know how to turn this into a JavaScript object. I get a little program in my brain that lets me do that. Great question. What else? Let's talk about responses. So responses look pretty much the same way. They have this kind of like meta thing up front. They also have headers and a body. Come on now, there we go. So we'll say, all right, well, the response I'm giving you is HTTP 1.1. Instead of a method, what do we get instead of a method that's kind of analogous? That's how you know whether or not it worked.
Like a status code or something?
That's exactly it. We get status code back. 200 series. Okay, it worked. It means 200 is okay, 201 is created, 204 is no content, but anything that starts with a 2 means something generally positive happened. 300 series starts with a 3. It means that I'm actually not handling this. I got a redirect. Starts with a 400 series error. That means the client fucked something up. What 400 series error were you probably familiar with before you ever started programming?
404.
404. 404 means you asked for something that does not exist. The client made a mistake. A 500 series error means that whatever the client did was okay, but it broke the server. .400 series, client fucked up. 500 series, server fucked up. So we get some message back that indicates just the overall status of the request. And with our client, we could say something like, oh, I asked for this and I got a response greater than or equal to 400. That means it didn't work. So on your client, you can trigger an error message or something as a result. Okay, so that's the first part of it. There are also headers. So I could say that I want application JSON. You can also say, I'll take any of the following 3 formats. That's also a thing you can do. Content type is what it actually ended up being. All right, so it ended up being application JSON. And same thing as the client, keys and values, keys and values, keys and values. And then the body is anything that they want to send us back. That could be the characters for HTML. That could be the characters for JSON. That could be nothing. We don't have to have a body. if I delete something, I don't expect to get anything back. What would it need to tell me? I just need to know whether or not it was actually deleted. I can do that with the status code. I request, I get a response. Magic. Ask us some questions about HTTP responses. Another related idea you may have noticed that when you're making a full stack app, you have to run 2 servers, don't you? What are the 2 servers you have to run?
Front end and back end.
Your front end server and your back end server. Why? What's your front end server doing?
It's making the request to your back end. It's got all your like app functionality coded into it.
It does, but I thought that was running in my browser. Why do I need to ask somebody else?
Because it needs the data to render, right?
Yep. So we have 2 servers that we work with. The API server, that's like the front for our database, right? I want some data. API server can get me that data, bring it back. But the reason I knew where that API server was is because my client told me. Not like JavaScript file, right? So we call this a file server. So what happens when I go to google.com, kylecoverly.com, whatever, is I look up where the kylecoverly.com computer is, and I go, hey, kylecoverly.com, would you have some kind of index for your site? And that file server goes, yeah, sure I do. Here is an index.html file. All of this is happening over HTTP. Browser says, yo, kylecoverly.com, give me an index.html file. Coming right up. Comes back to your client. Your client goes, I know what to do with these HTML files. I turn them into the DOM. So your browser munches up the HTML and poops out the DOM. This is another thing that I think new folk get confused about early on. Once that happens, there is no more HTML. The entire purpose of the HTML was to give the browser instructions on how to create the DOM. Once that happens, it throws away the HTML. It doesn't need it anymore. It goes, okay, cool. So I've got this DOM, and in part of the HTML file, it said, oh, I need this script file. Okay. Well, I'm also going to get the script file from this file server. And the CSS files, anything, images, anything that's just files. I'm going to ask that file server, and it gives it back to me. It gives me back a JavaScript file. It goes, oh, I'm a browser. I speak JavaScript. I know how to take these characters that you wrote in this file, and I know how to do something with these. So it starts munching through the JavaScript file, and it goes, oh, you want me to make a fetch request? I know how to make those. And then it makes a request to an API. API looks something up in the database, gives you an HTTP response. Life goes on. Almost every app that you make in this program has this shape to it. Ask me some questions about that.
This might be a little off topic, but if the DOM is a copy of the hard-coded HTML file that lives on a server somewhere, then the virtual DOM is a copy of the copy. Is that correct?
I would think of the first one less as a copy and more as a like output. The HTML is the input and the DOM is the output of it. It's a little less of a copy because our HTML, again, is just some fucking characters. Like, it's just a string. There's really nothing special about it. The DOM, however, is, so if we start with just these rando characters, that's the input. The thing it gets turned into is this tree structure that we call the DOM. And your browser has all kinds of like cool magic tricks it can do with this tree. But the instructions on how to build that tree, that's what the HTML is.
Okay.
But once it's been turned into that tree, then we can fuck with the tree with JavaScript. We can add stuff. We can remove stuff. We have this whole like cool event thing that happens that we'll talk about in Mod 3. But yeah, the file was just instructions. We throw it away as soon as we followed the instructions. I think one of the reasons that's confusing is, well, hey, doesn't this look like HTML? It sure does. This HTML was actually created out of the DOM. It reversed the process so that we can see what the HTML probably looked like. But if you've ever element inspected something, you go, well, that's not what I wrote. Well, that's why. It turned it into the tree, and then it turned the tree back into something that kind of looked like HTML. And then your question about the virtual DOM. The virtual DOM is a copy. We take that tree, and we make a copy of it. And it turns out that the real DOM is crazy slow. It's the rendering part of it. Once we get this tree, the browser has to render it so it like looks like something on the page. That part is slow as fuck. But with something like React, we don't necessarily need to render every little thing. We're doing logic with it. We're saying like, well, if this variable is true, then I want this thing to be in the new DOM. So you can do all of those calculations just in JavaScript with something like you make two trees and compare them and find out what's different. And then you only render the part that's different. That's a virtual DOM.
Okay.
It's an advanced question, Todd.
Hmm.
Cool. More questions about HTTP requests and responses. So we didn't talk about IP addresses. All I'll say about it right now is that there is no such thing as kylecoberly.com. There's a computer that has an IP address that kylecoberly.com is pointing to. But basically 11.0.32.251 is too hard to remember. And so we made these things called URLs that are just shortcuts for those. They map one-to-one URL to IP address, and then we have a telephone book that matches them together. We'll talk about that another day. But if there are no more questions about HTTP requests and responses, then what I would like you to do is, you're at a party, a real lame party. Oh, you're at that Flatiron school. They teach you anything about HTTP? I want you to brain dump everything that you know about HTTP right now. Activate your neurons. Get something firing. Let's find out how little you know about this while we're still here and we can answer some questions. We'll put 2 minutes on. Brain dump everything you know about HTTP. Go. Thirty seconds. Okay, so can be sloppy, can be wrong. I don't give a shit. I want to hear some answers. Indiana, what you got?
Sorry. It's just how to format messages and interact between clients and servers.
Okay, it is a format for messages. I like that part of it. Ryan, what you got?
I guess the thing that I was thinking most about was, I mean, this was really largely created to kind of, I suppose, like make these things more standard. So like the responses that get the post, those things used to be a lot more kind of all over the board. So it's a standard way to format these messages, I guess.
Indeed. And the standardization lets us do things like fetch. If I can send the message in a standard format and receive it in a standard format, now I can do things like, oh, if you send me strings and you call them HTML, I know how to deal with that. If everybody's making up their own format, much more difficult thing to do. Okay, Todd, what you got?
It's a, I don't know, it's a way for you to be able to send documents with like hyperlinks. Yeah, I don't. Yeah, and I kind of had it's a standardized way of making network requests and receiving network responses.
Yes. So like HTTP is more of that than the like documents and hyperlinks thing. That's on top of this. At the HTTP level, we kind of don't give a shit yet. We're asking for files, and then we're getting the files. What happens next is like, oh, this is a document. I know what to do with a document. I can link these documents together. That's like the web on top of this.
Okay.
But this is, I asked for something, I got something back. Very nice. And where's my mouse? There we go. Blake, what'd you get?
I think outside of what's already been said, you get, there's
We're not looking for original things. Give me like
well, you have a request and a response, and with that you send information and you get certain information back in order to understand what was sent as well as what was received.
Love it. Somebody asked you about HTTP request response. That should be like the first thing out of your mouth. That is like the core idea here, is that we ask for something, we get something back. Very good. Greg, what you got?
In order to be successful, it has to be two-way communication, round trip.
Yes.
And the parties that are having the conversation can be flip-flopped, contextual. Just the different responses. If it's 200 good, 300 redirect, 400 you're an idiot, 500 we're the idiot.
Yes. Let's say these are excellent. Very good, Greg. Talked about the different types of responses that we might get. Justin, what do you got? Justin there? Nolan, what you got?
Basically the same, about how it's like a form for clients and servers to send their information so that it can be transformed into something that the client or server can understand and then send back.
Absolutely. Any guesses? So like this makes sense. I asked for an HTML file. We get the contents of the HTML file. We send those characters back. Browser can like hydrate that into the DOM. Okay, easy enough. How about things like images? What do you think we're getting? How does that relate to HTTP? What's the HTTP response for an image look like?
It's just a bunch of fucking characters.
So it is a bunch of fucking characters. What kind of characters? Music file, movie. What's different about it? It's still just a bunch of characters. It's still an HTTP response. What's in the body?
Is it just a difference of the encoding?
Yes, it's an encoding kind of thing. How do you think it's encoded?
As a blob?
As a blob. What's a blob?
I only know of it as a data type for databases that would represent anything that's really not like a string, integer, decimal.
Super accurate. Do you know what it stands for? It's an acronym.
Nope.
Binary large object. That's another pretty big hint.
So there's a bunch of ones and zeros.
Bunch of ones and zeros, or something like that. Realistically, each of those characters takes up some space. And so like, that's maybe the least efficient way that we could send it. But you can do something like base 64, but it's still just representing numbers, just like binary does. And we go, oh, by the way, this is type image/JPEG. And your computer goes, oh, I can take this like really dense encoding, turn that into ones and zeros and run it through my magic JPEGifier. And then you see a picture. Cool, very nice. Jason, you have anything? Actually, I don't care if you're being repetitive. Brain dump, what do you know about HTTP?
All right, I wrote that it's a standard for web communication that involves a request and a response. HTTP requests come from a client and are sent to a server. The server sends back a response. The HTTP requests and response are comprised of a few components, one of which is a header, which describes the content coming in the body, which is the second section. And that's as far as I got.
Cool. Talked about different parts. They also have that like kind of meta part up front. Very nice. So now that you've like wrestled with explaining this, what lingering questions do you have about the HTTP request response cycle?
So what does the hypertext part of it mean?
So that's the layer above this. That's if, as I'm parsing this HTML into the DOM, when I see anchor tags, I take their href attribute and I go, cool, whenever this element in the DOM gets clicked on, I want you to tell the browser to go to whatever URL is in the href. That's the hyperlinking part.
Okay.
And then that kicks off another cycle of all of this. So when you click on that, it is going to some other computer and asking for an index.html file or whatever, and getting that back. And as it's parsing through that and turning that into the DOM, it's going to come across these link tags for CSS files. So then it asks for the CSS file. And it starts working through that. And then it'll get to a script tag and it goes, cool, can you give me the file that's the src attribute of this script file? And then it starts trying to chew through that.
Hey Kyle, on that on the top right there, what is the API server? What is south of that? The communication there.
That's the database.
Okay.
And like it's drawn poorly there, but that's a standard symbol for a database. If I say database icon, there you go. Anytime you see that in a diagram, they're talking about databases. Strictly speaking, that's a data store, which could also be like a file cabinet or something like that. But they're pretty much always talking about databases.
So was there ever anything else besides hyperlinks? Like how did we decide that was the standard?
So to some extent, HTTP is like right on the boundary of these two things, but some of this is web, some of this is internet. Internet is how do we get all the computers in the world to talk to each other? Well, we do that with IP addresses and DNS. DNS is that phone book that matches a URL to an IP address. We have protocols that we can talk to each other on. HTTP is one of them, which is why I put that pretty squarely like right here. HTTP is one of those protocols, but there's also POP. POP is Post Office Protocol. That's how your email works. There's also things like UDP. That's how your streaming games work. There's also a variety of different like video formats. We can do these as like one-off round-trip requests like we've been talking about. You can also do them as one-way requests. That's how like streaming video and stuff works. But the internet is just about how computers that are not physically co-located talk to each other. The web, and like that's the thing when they're like, you know, this actually goes back to the 60s. That's what they're talking about, is just having remote computers talk to each other. The web is on top of that. This is like 1991. This is the thing that came out of CERN. This was Tim Berners-Lee's creation. He's like, what if I made this application, I'll call it a browser, that I can punch characters into, and it'll look up documents, and then I can serve up documents. So he's a researcher. He wants to share his research docs easier than like faxing them to people. All right. So if you're starting with the presumption that this is all about sharing documents, well, documents reference other documents. So he came up with the idea of the hyperlink. And there was actually like concurrently a similar model for that called HyperCard that I think came out of Apple. That was like trying to solve the same problem in a slightly different way. And it ended up being one of those Tesla things where I think HyperCard was technically a better way to do it, but through the underhanded means and weird political circumstances and whatever else, hyperlinks kind of ended up taking the day. But same idea. I want to share this research paper. It's also linked to these research papers and these research papers and these research papers. And you click, you take one of these mouses and you click on the thing and it takes you to the other document. That's also why we still call them documents to this day, even though now we use them to make applications and whatever else. But it was supposed to be just researchers sharing their research. That also coincided with the government deregulating the internet, like I think that year. Because before then it was like only for university or military use. And like 1990, 1991, government goes, fuck it. We can't figure out how to do anything useful with this. You can try like commerce if you want. And now it's 2020. Cool, what else? Going once. Going twice. Sold. Thank you much, everybody.
Thanks, Kyle.
Yep.